Right now, inside the world's biggest companies, there is this uh, massive and honestly incredibly expensive fight over three specific words.
Oh, absolutely. It's everywhere.
Right. And depending on how an enterprise actually defines these three words, they're either going to save millions of dollars in operational efficiency or, they are going to build a totally useless, chaotic piece of software.
Yeah, which happens more often than you'd think.
Exactly. And for you, listening right now, you are probably hearing these exact same buzzwords flying around your office or in the news, and you're trying to figure out how they fit together, or honestly, if they even do fit together.
Right, because the current landscape is, well, it's the absolute definition of diagnostic muddy waters.
Yeah, that's exactly what it is. So that is our mission for today's deep dive. We are going to completely cut through the noise, demystify the jargon, and figure out what is actually happening under the hood of modern enterprise AI.
Which is entirely necessary because you've got startups, engineering teams, and massive corporate boards all using the exact same vocabulary to mean completely different things.
It's a mess.
It really is. It leads to wildly misaligned expectations across the board.
So to solve this, we are unpacking a really fascinating piece of research by Shish S over at Microsoft. He essentially decided to study how these terms are actually functioning in real-world production environments in 2026.
Yeah, getting out of the theoretical and into the practical.
Exactly. And the specific terms we are tackling today, the ones causing all this friction, are agent, orchestrator, and, surprisingly, a concept called the claw.
What's fascinating here is that the core thesis of this research completely shifts how you should look at these systems.
How so?
Well, most people treat these terms like a multiple choice question. They think they need to pick one architecture to buy or build.
Like, do we want an agent or a claw?
Exactly. But Shish points out that these are not competing technologies at all. They actually describe different evolving layers of the exact same ecosystem.
Okay, so they aren't rivals. They are basically building blocks that stack on top of each other.
Precisely.
Which means before we can understand the massive overarching system, we have to start at the foundational layer. We have to look at the individual workers doing the heavy lifting, the doers.
Right. And in this ecosystem, the doer is the agent.
Okay, so define that for us. What makes an agent an agent?
If we are defining that foundational layer, an agent is fundamentally purpose-built. It is incredibly outcome-driven, and it operates within a strictly defined scope.
So it's not trying to do everything.
Not at all. It is a composable piece of software that simply does the work. You give it a specific goal, it takes in data, and it executes a specific action.
Okay, let's unpack this. Because when most people hear the phrase AI agent, they picture this, like omnipotent general intelligence.
Oh, sure. The sci-fi version.
Right, they picture a sci-fi entity that can write a marketing email, balance the company checkbook, and optimize a global supply chain all at the exact same time.
Yeah, and that's just not reality.
Based on this research, it's much more like a specialized line cook in an incredibly busy restaurant kitchen. You have one cook who, only chops vegetables. That cutting board is their entire universe.
That's a great way to look at
And
it.
you have another cook who only grills meat. But, and here is my pushback, if these foundational AI models are so highly intelligent, why restrict them?
What do you mean?
Like, why do they have such a narrow scope? Why can't a single massive agent just run the whole kitchen operation?
That goes straight to the reality of how enterprise operations function. Specialization isn't a limitation. It is the core mechanism that ensures reliability.
Reliability, okay.
Yeah, because when you use a generalized AI model to do everything, it has to guess context, and when it guesses, it can hallucinate or make assumptions that are just slightly off.
Right, which we've all seen ChatGPT do.
Exactly, and if a generalized AI is writing a poem, slightly off is fine. But when you are running a global supply chain, if an AI decides to substitute a missing palette of industrial microchips with a palette of potato chips, just because the words look semantically similar in a database, that slightly off decision halts a manufacturing line and costs millions of dollars.
Right. Microchips to potato chips is a very expensive typo.
Extremely. So specialization ensures strict mathematical accuracy.
That makes total sense. You want the vegetable chopper to only know about vegetables so they never accidentally throw a steak into the salad.
Precisely. And the source material highlights several startups that are currently delivering these highly focused, narrow-scope agent capabilities in the real world right now.
Let's run through some of those.
Sure. So let's look at the mechanics of a few of them. There is a startup called Nimble. And they provide agents specifically for what the industry calls external demand sensing and digital shelf monitoring.
Wait, let's translate that.
Yeah.
External demand sensing basically means this agent's only job is to look out the window, watch the weather, monitor market trends, and figure out what customers are going to want to buy tomorrow.
Right. That captures it perfectly. It is entirely outward facing.
Got it.
Then you have another startup called Wyadustry. Their agent is purely focused on internal inventory rebalancing.
Okay, so totally different job.
Entirely different. It constantly calculates the cost of moving unsold products against the cost of putting those products on clearance.
So Wedustri is the agent that realizes, hey, we have 2,000 heavy winter coats sitting in a Miami warehouse in April, and a late blizzard just hit Chicago.
Exactly.
Let's physically move those coats up to Chicago where they will sell at full price rather than leaving them in Miami to be marked down to $5.
Yes, and it does the complex math on shipping costs to ensure that move is actually profitable.
That's incredibly smart.
It is. And moving inside the physical store, you have a startup like OmniStream. They deliver agents for in-store assortment and planogram compliance.
Wait, planogram compliance, that's just corporate speak for making sure the physical layout of the store actually matches the blueprint that headquarters drew up, right?
That's exactly what it is.
Like making sure the premium toothpaste is actually on the eye-level shelf.
Right. The agent takes in visual data or inventory scans and cross-references them against the master blueprint, automatically flagging any deviations.
Wow, okay.
And this narrow focus extends beyond physical goods, too. The research mentions personal AI, which builds domain-trained assistants grounded entirely in a specific enterprise's proprietary knowledge base.
So a totally walled-off, highly specific assistant.
Yes. And then there's Augur, which delivers what they call agentic automation specifically for supply chain exception management.
Let's bring that back to the kitchen analogy.
Hmm.
Exception management is essentially the agent figuring out what to do when the supplier completely forgets to deliver the chicken for the night's dinner service. Right? It's handling the unexpected failure.
Exactly that. The Augur agent detects the missing delivery, instantly reviews alternative suppliers, checks real-time transit times, and automatically issues a purchase order to get replacement chicken to the back door before dinner service even starts.
That is wild. And every single startup we just named is basically building a different line cook.
Right. They are mastering one tiny sliver of the operation.
So for you listening, the core takeaway here is that when you hear the word agent in an enterprise context, you should immediately picture a highly specialized, single-task micro-worker. You shouldn't picture a generalized do-everything AI.
Together, those microworkers form the building blocks. But, and this is key, if we follow your kitchen analogy to its logical conclusion, a room full of individual line cooks working completely independently is going to hit a critical failure point.
Oh, absolutely. It would be pure, uncoordinated chaos.
Right.
If the vegetable chopper doesn't know what the grill cook is doing, you end up with a plate of raw carrots and a burned steak.
Which nobody wants.
Exactly. Without someone standing at the front of the kitchen, calling the orders, pacing the tickets, and making sure the entire meal comes out perfectly timed, you just have noise.
Yes.
And that causal connection, the actual need to manage the chaos, is what introduces our second buzzword, the orchestrator.
The orchestrator is the management layer. If we look at the mechanics, orchestrators define how the individual agents work together.
So they're the ones calling the shots.
Basically, they handle task routing. They manage dependencies, meaning they enforce the rule that Agent B cannot begin its analysis until Agent A has finished pulling the data.
Make sure the chicken is here before you start cooking it.
Precisely. They handle the workflow sequencing, and they manage the handoffs between agents.
So the orchestrator is the kitchen manager. But the source material points out a really crucial distinction here about how orchestrators actually operate.
Yeah, there is a fundamental limitation to what they do.
What is that?
It is a limitation that defines traditional software architecture. In most enterprise systems, orchestrators sit strictly inside an application,
Okay.
which means they are entirely reactive. They only run when they are explicitly triggered.
Ah, I see.
A human user has to type a prompt, or a specific system alert has to go off. That trigger wakes the orchestrator up, it coordinates the agents, it completes that specific workflow, and then it stops. It just goes back to sleep.
Right. It's waiting for the next ticket to print in the kitchen. If no ticket prints, the manager just stands there staring at the wall.
Exactly. The research gives us a clear look at how this mechanism works in practice, specifically within the Microsoft stack. It actually shows up in two distinct ways.
Okay, lay them out for us.
First, you have the Azure Agent Framework. In this model, orchestration is deterministic and explicit. Developers are firmly in the driver's seat.
So it's very manual.
Very. They write hard code to define the exact workflows, the strict routing, and the control across multiple agents.
So that's for the engineering team that wants absolute granular manual control over exactly how the line cooks behave. Like, if X happens, trigger agent Y.
Right, but on the other side of the spectrum, you have Copilot Studio. Here, the orchestration is embedded and generative.
Generative.
Yeah, instead of a developer hard-coding the routing, the system relies on semantic matching.
Wait, explain the mechanism there. How does it know what to do if the developer didn't actually write the rule?
It interprets intent.
Okay.
So a user types a natural language sentence into Copilot, like, I need to resolve this sudden inventory shortage in Dallas.
Right.
The embedded orchestrator analyzes that sentence, understands the underlying goal, and then looks at its available pool of agents. It realizes, I need the demand sensing agent to check the forecast and the logistics agent to check warehouse stock.
Wow.
The orchestrator dynamically builds the workflow on the fly, wakes up those specific agents, and routes the data between them.
That completely shifts the burden away from the programmer and onto the AI. You just described the problem in plain English, and the embedded orchestrator figures out which line cooks to wake up.
Exactly. Both the Azure Framework and Copilot represent the exact same layer, the
Right.
orchestrator. One is rigidly defined, the other is dynamically generated.
That's a great distinction.
And the research also notes that some platforms serve as massive cross-department orchestrators. It mentions a startup called EMA.
Oh, EMA.
Yeah, EMA connects the dots between entirely different enterprise silos, enabling workflow automation across operations, human resources, and customer experience. It acts as a universal translator between different departments' agents.
But even with a system as incredibly powerful as EMA or Copilot Studio, we keep coming back to that fundamental limitation, don't we?
The reactive nature.
Right. The orchestrator is entirely reactive. It is waiting for a human to type that prompt about the Dallas inventory, or waiting for a specific database trigger to execute.
Yeah, it has to be told to start.
And if you are running a fast-paced enterprise like a global retail brand or a major telecom, waiting for a trigger is a massive bottleneck. You
Yeah.
can't have your entire intelligence layer just sleeping, waiting for someone to notice a problem and push a button.
No, you can't. And that bottleneck, the delay between a problem occurring and a human noticing it to trigger the system, is exactly what drives the evolution to the third and most uniquely named concept in our deep dive today.
The claw, which honestly sounds like the villain in an 80s cartoon. I love it.
It does, but if we connect this to the bigger picture, the claw represents a massive architectural leap in enterprise software.
How so?
A claw is fundamentally different from an orchestrator because it is persistent, it is proactive, and it exists completely external to a single application.
So it doesn't sleep.
It doesn't sleep. It runs a continuous loop, constantly monitoring signals from the environment, evaluating state, and delegating work to the agents completely without waiting for a human request.
So does the claw replace the orchestrator? Like, do we fire the kitchen manager?
We don't. The layers stack. The orchestrator still exists, but it now sits inside the claw.
Interesting.
The claw acts as a persistent living shell around the orchestration logic. It is the definitive shift from a request-response architecture to an always-on AI operation.
Here's where it gets really interesting, because I think I have the perfect analogy to visualize this shift.
Let's hear it.
Think about the heating and cooling in your house.
Mm-hmm.
An orchestrator is like a traditional digital thermostat on your wall.
Yeah.
It's smart, right? You can program it to wake up at 6 a.m., turn on the heat to 70 degrees, and then shut off.
Sure.
But it is fundamentally reactive to the rules you gave it. If a sudden, unexpected freeze happens at 2 a.m., it doesn't do anything unless you manually walk up and tap the screen to trigger a new command.
Right. It executes its defined workflow and stops.
But a claw is like stepping into one of those ultra-modern, fully integrated, smart climate systems. You never touch a dial. The system is continuously monitoring the weather forecast outside. It's sensing how many human bodies are currently generating heat in the living room. It's checking the humidity levels in the basement. And it is proactively, continuously adjusting the temperature, opening vents, and closing blinds without you ever asking it to do anything.
Yeah.
It just maintains the perfect environment.
That captures the core mechanic perfectly. The claw operates on a continuous heartbeat. It is an endless loop of evaluating conditions against the desired state and acting relentlessly to bridge any gaps.
Conceptually, that makes total sense.
Yeah.
But I want to bring this down to earth for a second.
Okay.
Understanding the theory is great, but why is this specific claw model suddenly gaining so much traction right now? Why is it moving from theoretical whiteboards to actual production environments inside massive companies today?
Well, according to Shish's research, there are three critical capabilities driving this rapid adoption. The first, which your thermostat analogy highlighted, is
A
persistence.
heartbeat.
Exactly. A claw runs on a continuous heartbeat. In the real world, timing is everything. You cannot wait for a daily batch report at 5 p.m. to tell you that a supply chain node failed at 9 a.m.
Definitely not.
The system needs to be checking state constantly, so it can react in seconds, not hours.
Because business doesn't happen in batches. It happens constantly.
Exactly. The second capability is messaging native interaction, and this is vital for human adoption.
How does that work?
Operators do not have to log into some complex, clunky dashboard to interact with the claw. They engage with it through the tools they are already using every single day, tools like Microsoft Teams, Slack, or even WhatsApp.
Wait, let's pause on that because that completely bypasses the traditional software model.
Yeah.
You're saying a multi-million-dollar always-on enterprise AI system is basically texting a store manager on WhatsApp to tell them to fix a shelf.
That is the exact workflow. It forces the AI to adapt to the human's workflow, not the other way around.
That's incredible.
Right. If the claw detects a critical inventory shortage, it doesn't just log an error in a database. It actively sends a WhatsApp message to the floor manager saying, "Aisle 4 is out of stock. I have already dispatched a robot from the back room with the replacement pallet. Please confirm when the shelf is restocked."
Wow.
And then the manager replies, "Done," right in the chat. And the claw logs the completion and updates the system state.
That is almost conversational operations. But hold on. If this system is texting people and making autonomous decisions about inventory and logistics, what about security?
That's a big question.
Yeah, because you can't just have an AI running loose with a company's core financial and operational data, especially if it's interacting over commercial chat apps.
Which brings us directly to the third capability, controlled deployment. These claw systems aren't floating in some mysterious public cloud where an enterprise doesn't own its data.
Okay, good.
They are deployed within tightly controlled enterprise boundaries. They sit locally, extremely close to the company's core databases.
So they're locked down.
Completely. This means they operate within strictly defined security, compliance, and governance rules. All the data processing happens internally, maintaining incredibly low latency and absolute data privacy before it ever sends that simple text message out to the manager.
It keeps the company secrets locked in the vault while letting the AI run the building. Now, the source material uses the retail and consumer packaged goods industries to illustrate this entire stack in action. Why is retail the perfect testing ground for a claw?
Because retail is the ultimate test of what we call continuous time. Think about a massive grocery store.
Okay.
It is essentially a giant, chaotic math equation where variables are changing every single minute. Pricing, inventory levels, foot traffic, competitor promotions down the street, none of it is static.
Yeah, that makes sense.
If you rely on a traditional orchestrator, a store manager has to physically notice a gap on a shelf, walk to a backroom computer, and trigger a request to reorder.
Which means that shelf sits completely empty for hours, and you are actively losing revenue from every single customer who walks past it.
But with a claw, you have a persistent system continuously monitoring the point-of-sale data and shelf sensors in real time. Let's trace the data flow. Say the claw detects a massive, sudden surge in demand for umbrellas because a thunderstorm just started outside.
Oh.
It instantly calculates that the current shelf inventory will be depleted in 14 minutes.
It's doing the math before the shelf is even empty.
Exactly. Without waiting for a human trigger, the claw wakes up the inventory agent and commands it to initiate immediate replenishment from the back room.
Incredible.
Simultaneously, it wakes up a pricing agent to slightly discount a slow-moving item in the adjacent aisle to clear physical space for more umbrellas.
Wow.
It routes all of this through the internal orchestrator logic and then pings the aisle manager on Teams to let them know the new umbrellas are arriving in 2 minutes. It handles the entire crisis instantly, continuously.
It's like having a ghost manager who can see every single product, every single customer, and every single price tag in the store simultaneously, constantly adjusting the dials to maximize efficiency.
That is exactly what it is.
So what does this all mean for you, the listener? Let's bring all these pieces together. If we go back to our initial mission of cutting through the jargon, you now have a highly structured mental map.
Yeah, hopefully it's much clearer now.
When you hear the word agent, you know that is the foundational layer for execution. The individual highly specialized micro worker doing a narrow task. The vegetable chopper.
Right.
When you hear orchestrator, you know that is the internal coordination logic. The manager routing the tasks and managing the dependencies, but only when prompted by a trigger.
Exactly.
And when you hear claw, you know you are looking at the persistent, always-on shell that never sleeps, proactively monitoring the environment and waking up those agents to keep the enterprise running continuously.
They aren't competing products.
Right. They are the natural evolution from a single task to a managed workflow to a living ecosystem.
This raises an important question, though, and it's something Shisha's research implicitly prompts us to think about as we look toward the next 5 years of enterprise architecture.
Let's hear it.
If we are actively moving operations from these human-triggered request-response systems to an always-on continuous operation managed by a claw, what happens when the human is no longer the trigger but the bottleneck?
Ooh, that is heavy.
If we look closely at the mechanism, a claw is relentlessly monitoring signals, processing vast amounts of data, and anticipating needs in real time.
Yeah.
It will inevitably reach a point where its predictive models can make operational decisions faster and mathematically more accurately than the human managers overseeing it.
It's a crazy thought.
If the claw knows the umbrella demand is going to spike before the rain even starts, having a human approve the pallet move simply slows the system down.
Right.
How much autonomy are we truly prepared to hand over to a system that never sleeps? At what point do we stop checking the claw's work and simply step out of the way entirely?
That is a staggering thought to leave on. Building a system so hyper-efficient that human oversight actually becomes a liability to the operation. It really makes you rethink the digital infrastructure we interact with every single day.
It really does.
So, for you listening, here is your homework. Over the next few days, look at the software, the apps, and the internal tools you use to do your job. Look at the mechanisms behind them.
Dig a little deeper.
Ask yourself, am I interacting with an agent, just executing a specialized task? Am I manually triggering an orchestrator? Or am I participating in an always-on persistent system? Look for the claw. Because once you see how these layers actually stack, the muddy waters of enterprise AI suddenly become crystal clear. Thanks for joining us on this deep dive.